Okay, so today we're talking about adding and subtracting rational expressions. Now to add and subtract fractions with different denominators, just like we did for our problem today, okay? You basically got that common denominator, that same denominator in the bottom. And then we basically multiply the top and the bottom by whatever we needed to create that common denominator. Yes? Isn't that what we ended up with for our problem today? Okay? It is the same type of concept when you're doing it with rational expressions, okay? You need to have a common denominator. So sometimes you might have to factor to see what factors they already have in common and what factors they're missing, okay? And then that's what you multiply the top and the bottom. You have an example that's already worked out here, all right? I'm not going to go over that example, but it's there for you. There's something else for you to have, all right? We're just going to jump right on into it. So, starting off simple, we'll work our way up. Now, in order, again, to add these two, we need to have a common denominator. And I guess the easiest way to do it is, what is this denominator missing from this one? It's missing an x squared. So that means I'm going to multiply the top and the bottom by an x squared. What is this denominator missing that this has? A 2. So I'm going to multiply the top and the bottom by 2. Okay? Everyone all right so far? So when I multiply x squared by 1, I get x squared. On the bottom, I'm going to have a what? 2x squared. For the other part of the fraction, 3 times 2? 6 over what? 2x squared. Now that I have a common denominator, I can just add the top. So then I'll get x squared plus 6 over 2x squared. All right? Now from here, this is kind of like what we were working with yesterday, with simplifying rational expressions. All right? So from here, then you want to do what we have been doing. Okay, we want to factor the top, factor the bottom, see if anything can cancel out. But I have a question. Can I factor the top here? Is that greatest common factor? Is this difference of perfect squares? So I can't go any further than this. So this is my final answer. All right? But once I do get to that one fraction, that's what I want to do after that, okay? Following me so far? Okay, let's look at another one. Alright, look at the bottoms. Now, it's not just a monomial like how the left side is. So what do you think I should do to the right side? Say it again. Wait. Okay, what do you think I should do here? I can take out an x. Can I take out anything else? A 2. I can take out a 2x. Isn't that the greatest common factor of the bottom? What am I left with? Then x plus 3. Okay? Factor your bottom. So then that way you can see, okay, what things do they already have in common? In order to add them, they have to be the same denominator. So what is the left side denominator missing that the right side has? So that means I'm going to multiply the top and the bottom by an x plus 3. Is this denominator missing anything that the left side has? So you do nothing to that side. Okay? Now let's multiply. 3 times x plus 3 gives me what? 3x plus what? 9, because you distribute. At the bottom, I'll have a 2x times x plus 3. And I did nothing to the other fraction, so that stays the same. Now that my denominators are the same, all I have to do is what? What? Add the what? The top. So, this gives me 3x plus 9 plus x. So I'll have 4x plus 9 over 2x, x plus 3. Now, gotta be careful. This is a 4x plus 9. If it was 4x times 9, then I could cancel out the x's and then simplify that. But can I go any further than this? No, so this is my final answer. So you guys see how it goes? See how it works? Okay, let's do one more together, and then I want you to try a couple on your own. All right? Number 3. Can't really factor the bottoms, can I? So now I just got to get a common denominator. What is this? What is the left side missing that the right side has? A what? No, the bottoms. It's an x plus 1. And I say it's missing a 5 because this is an entire expression together. If it was a 5x or something like that, then maybe you could say that. But you have an x plus 5 on the left side and x plus 1 on the right side. So in order to get a common denominator, basically this whole side is missing an x plus 1. This whole side is missing an x plus 5. You see that? Common denominators here. The side's missing an x plus 5. Over here. So now, you multiply. On the left side, what are you going to have? 3x plus 3. The bottom is going to be an x plus 1 times an x plus 5. On the right side, what are you going to have? 4x plus 20. The bottom, you'll have an x plus 1 times an x plus 5. Okay, remember, you distribute. You distribute. And now that I have the same denominator, add what? The top. 4x and 3x make 3 and 20 make 23. At the bottom, I'll have x plus 1, x plus 5. Can I go any further? Can I simplify the top? Do I have greatest common factor or anything? No? So then we're done. Okay? Yes?
So you'll never, like, multiply the bottom out, like, x plus 1, x plus 5, they always just come straight down.
Well, you can multiply these out, but the thing is, if the top can be factored, the only way you'll see if it's going to cancel out with something in the bottom is if it's in factor. But if nothing cancels out, then yeah, you can go ahead and FOIL this and then have the quadratic be the final answer. Or you can just leave it like that. Alright? So I want you guys to try, we're going to try a few more. Let's try 4. Let's try 5. And let's try 7. 4, 5, and 7, okay? That's the ones I want you guys to. If you factor, again, you see that the left side is only missing an x plus 1, the right side is missing nothing. So then that leaves you with an x squared plus x on the left side, and the 3x on the right side. You do nothing. It's the right side. So then when you add them together, you'll get x squared plus what? 4x over x plus 1 times x minus 1. Can I factor the top? I can take out an x, and that leaves me with what? The x plus 4. The bottom still stays x plus 1, x minus 1. Could I cancel anything? No? So either of these, either this one here or this one here would be acceptable. Okay? But at least leaving the bottom factor, you can see if anything were to cancel out. Alright? Let's look at number 5.
Could you have FOILed out the bottom?
Yes, you could have foiled out the bottom over here, and then you would have had x squared minus 1. But you don't cancel out the x squared, then you can't cancel it. Alright? Now look at number 5. What should I do first? Factor. can't do nothing to the left side, but I can factor the right side. Factor out an x. That leaves me with what? An x plus 2. And you'll see that the left side is just missing what? An x. The right side? Nothing. So then I have a 2x squared on the left over an x times x plus 2 minus an 8x times x plus 2. I have a common denominator now, so I can subtract them, right? 2x squared minus 8 over x plus 2. I can take out the 2 from the top, that's my GCF. When I take out the 2, what am I left with? And then you can factor out the x squared minus 4, right? That is what? X plus 2, x minus 2. Do you see something? The x plus 2's cancel out. So my final answer is 2x minus 2 all over x. Right? That's one of the benefits of leaving your denominator in that factor form, so that way if the numerator does factor, you can cancel out some common factors there. Okay? But factor that bottom first, okay? Don't make it any more difficult on yourself than this already is. Okay? Last one, 7. So here's your answer to number 7. Again, you have a negative, you're subtracting this entire right side, so that's a negative x, and then a minus negative 2. 2 negatives make a positive. Questions? Okay.